Hey everybody, this is Larry. I'm doing this problem as part of a contest, so you're gonna watch me live as I go through my dots as I'm coding. There'll be an explanation near the end, and for more context, there'll be a link below on the actual screencast of the contest. How did you do? Let me know how you do. Hit the like button, hit the subscribe button, and here we go. Q4, constraint subset sum. Yeah, so this one I had a little bit trouble with, or a lot of trouble with. I refreshed and someone already finished. Uh, which is yeah, it's pretty impressive. Um, but, but yeah, this one I was just having. Well, I just didn't. Well, I think here I think I understand what I had to do, but I just wanted to make sure, and I didn't really. At first, I was going to do dynamic programming. To be honest, that's why you saw the spaces. I was going to write input functors, or from functors import LRU cache, and I was like, oh wait, k is actually 10 to the fifth, so you can't do n squared. So dynamic program would have been n squared. Um, it also would have been easy to write, but then now I'm trying to think about like, okay, there must be a greedy type thing. Um, and I was also trying to figure out what a subset means, because subset actually means a little bit weird the way that they have it here, because usually subset does not mean leaving the remaining elements in their original order. Uh, Usually, I don't know. Maybe that's just my reading thing. But either way, so I had to double check that one and understand it again. We only spent a couple of minutes here just reading this one, and I'm just thinking about how to do it. I think at this point, I started to have an idea of how to do it. However, I was just trying to figure out the right data structure to it. Um, and basically, what I wanted to do was a sort of a rolling window type thing. Yeah, and at this point, yeah, just deep in thought about how to solve this at all. And I think for now, maybe I'm not into the solution yet, because I think what I was trying to do now is just thinking about like how to prove it correctly. Like I wasn't sure. Like I was trying to convince myself that the rolling window makes sense, um, and then and this is the time that you spend here is time that it's time that if you had practice enough, you would not have to spend, and that's or like not practice enough, but you also if you have done similar problems, maybe more recently, then you wouldn't have to do this because then you would just be like, oh yeah, I did this similar problem. But for me, I was a little bit rusty with these kind of rolling window problems lately, uh, and and I was just trying to prove to myself that this sort of greedy makes sense. And I think actually at this point, it's kind of actually I had an interesting thought is that at this thought because I was still thinking about dynamic programming, and the dynamic programming is there are a couple of ways to write this dynamic programming, but one way that I was thinking about at this point, because initially I was just like, oh yeah, just write a dynamic program on n and k, and then you could do this sweeping through the n and the k, and it'll be n squared and so forth. And then the second way that you could do it is that actually looking at each index, you could look at it as a sort of a longest path in the DAG. And from that, you also it's still n times k. So it's no longer well, I mean, it's still n times k because you have to do a look back on the previous k. So that was my thought process about it. And then and I still know that n times k is not going to be fast enough, obviously, for 10 to the fifth. And then from here, I think I was beginning to think, well, when you write out that dynamic programming, what are you doing, right? Well, you're just finding the max of the last k items, and then um, and then getting the max of that, and then add it to the current element, right? So from that, I was trying to figure out like, okay, that makes sense. So actually, what you really want is a sort of a sliding window. So that's how I did the deduction, or that's how I deduced the answer, I guess. I don't know. Now I feel like I'm Sherlock Holmes, but But that's how I arrived at this solution where I was like, okay. And then from that, it was a little bit implementation detail. So I'm still, even if I got it now, so I'm trying to be a little bit careful about it. I was trying to look up. So one thing that is unfamiliar for me in API was that I wasn't sure that, like given an ordered set or like a sets ordered in Python, and the answer to that is apparently no. I don't think so. In the way that I just wanted to be able to get the min item from, or in this case, the max item. But uh, yeah, the max item. Oh yeah. So yeah, what I wanted to do was given a priority queue, or given a bag of stuff or a set, get the max item from that set so that you kind of you insert stuff in when you process a number, and then you remove something that you've seen before. So that's kind of the idea. And then instead, I did things with a priority queue because, or a heap, if you will, because I was like, I don't think set does this. And I spent too much time Googling when I knew I was like, okay, I could just do it in heap. I mean, you lose that instead of n log k, you get n log n, but that's okay. Like, especially for contest mode. And I haven't been heaping a while, so there's some rustiness there about the exact syntax. And I think so here I misunderstood the problem. I thought you had to choose the first element. Um, so that's kind of that leads to the yeah, I mean, I'm still thinking if we're just trying to, I think I'm just still having a little doubt and thinking about how to exactly implement this. And that, again, is something that can be practiced. And if I was more practice on this farm, then I would have done it. But that's okay. I mean, contests could practice too. Uh, so but yeah, but now I just keep track of the index, and we're just making sure that. So my idea here was that it's with this way of doing. So I was trying to figure a way to remove it, like okay, like what we talked about earlier. There's a bag, and we're trying to remove elements from the middle as they kind of drop out of your rolling window. Um, and I was like, okay, I don't there's no data structure to it. And then what that reminded me was of Dijkstra's algorithm. So one implementation of Dijkstra's algorithm is that well, when when you relax a node, you take you remove that node from the Dijkstra heap, right? And I was like, well, the hack around that one is that instead of getting relog re, you do a relog ye type thing, which is you could prove that log ye is um, since ye is at most square is two times whatever. But anyway, not getting too much into that, but the idea of that is that you only get slightly worse performance. But here, so what I did instead was that yeah, instead of getting an n log k performance, I get a n log uh, n log n performance, and that's the way I did it. But I misunderstood this problem a little bit in terms of the boundary cases. I didn't really think about it that much. I was rushing a little bit probably mentally. I'm about 16 minutes in now. If I had finished now and got it correctly, I would have been still top 20. So that would have been really good. But I did try to put, so I did have an issues here because I forgot for a second that that Python is Python is min heap instead of max heap. So that's where a lot of my issues that you're seeing is to right now. So that I mean, I knew that, but I think I don't know, like, I think some of that was that I was a little bit like trying to rush it a little bit, and from that I was I distinctly remember that in the beginning. I was like, I remember this in Python heaps are a little different. So I knew that because I've done it enough, but I think in the moment I was rushing a little bit too much, and then I didn't. And then yeah, now I'm looking at the code. I'm like, huh, why does that not make sense? Why is it taking the zero instead of whatever, uh, yeah, whatever it is. Yeah. So now I was like, okay, well, I was like, this is still not right. So yeah, I had the index and the previous index swapped. So I went and it runs. So I was like, okay, let's go. This would have been about 19 minutes in. Still good for the top 25 if I had gotten it right, but I got wrong answer. I was like, oh, this is sad. And then I took a look at this and I was like, oh. So I took the wrong lesson from this, which is a little sad. What I thought was that you need the first element from the previous thing, but I was like, oh, actually, you don't need the. I don't know. That line also was a little problematic, but in that interpretation, so it was just a little buggy in a weird way. Um, yeah, so now I set it to the first element because I just misunderstood it. Uh, but after testing it, yeah, I was just trying to figure out. So what I thought at this time, and I still misunderstood it, but what I thought was that the first element has to be k distant from the beginning of the matrix or from the beginning of the array, which I don't know why I thought that now looking back, but at the time I was like, oh, that makes sense. Why not? Um, so that's why I wrote, I created this like set no value from the beginning so that it fixes that case. Yeah, but I just misunderstood it. I really thought that it was just that you had to get something from the beginning. Otherwise, I would have solved it another way, or at least I would have tested a little bit. Uh, but that's the tricky part about contests sometimes is that, you know, and then when I submit, I was like, oh, this, well, I felt a little sad. I looked at this example. I was like, huh, let me try to understand this. Let's run the code. Let's bring back the debug. And I was like, oh, that's just a lot of negative numbers. How do you get 16,000? Um, and yeah, and I eventually do come to my senses and that found out that, or figured it out, that you can actually start from any index. And then I rewrote it. It was a little bit sad because like that was 10 minutes of penalty. Like the time spent was like, okay, like actually just didn't, I just solved the wrong problem kind of. Um, but but the 10-minute penalty kind of hurts. I wish that, I think if I had gotten, like if the first wrong answer was this one, then I would have just gotten it. Then I would have understood it, and then it would have saved me 5 minutes at least in penalty. So it's kind of a little unfortunate, but sometimes,
Oh, you could start from anywhere.
you know, like to do well in a to do consistently okay on a contest, you just have to be consistent. You have to be, have solid, and you have to be, you know. But to do really, really well, like something at least for me, well, needs a little bit of luck, and maybe today I just didn't have that on my side as much. But like I said, if uh, if I misread a couple of things and got a couple of things wrong, and I'm still 110th, I'm not gonna complain that much about it. But my only kind of complaint is that waste opportunity, because on the first three prompts I solved it in 8 minutes, which is fast for me. And if I just got an average, maybe like even a decent time, maybe not average, like actually even like the current time. If I got the current time but without the two penalties, I would have been top 50 or something like that, right? So sometimes, it is what it is. But uh, yeah, right. Chat, hang out with the other Larry, ask questions, and I'll see y'all. Well, the other Larry will see you. Minutes. This one took about 5 minutes to read in general. We got this really quickly. Mad props to them. Um, but yeah, I think well, I mean, the 23 minutes was okay. Like, I don't feel that bad about it. It's a problem that I just feel like I haven't done before, so it's okay. Or like I had an idea, but it took me a little bit of kind of formulating it, and that's okay, right? Because not going to be amazing every time. Well, I'm not going to be amazing every time. That's okay. Um, but but yeah, what did I get? Well, one of them was that you can start the way anywhere, so you didn't have to start from the point zero. Um, but but yeah, I don't know. I forget what my other. Let me check my other submissions, um, and then I'll go over my explanations bit of it. But is that my second solution? Yeah. Yeah. Okay. Well, what was my first one? Uh, Now the first one was me being dumb on. No, this was actually this ended up being right. It's just that I just misunderstood. I mean, this was still wrong, but this line is right. Um, it's just that I think well, at this point, when I quote unquote fixed this, I misunderstood what it needed to be fixed, which was I forget what the example case was now. Example case was this case where, oh yeah, where you don't start from the first. So the issue that I thought I was having was that you don't start from the begin, or like you could do two offset from the beginning, and then I fixed it the wrong way. So I probably could have saved 5 minutes without not being dumb. Uh, Still 3 minutes. I'm not gonna make it that much, but yeah. But the idea here is actually a sort of a rolling window, if you will, or sliding window, even though it's not intuitive. Um, I was thinking a little bit about the ways to kind of go about the sliding window, but the idea is that you just the keep keep track of all the sum of all the previous case um, of the so, and then you yeah, so you keep and you could think about it as keeping a bag, if you will, of the last case of the sums, and actually this one I could probably just do max of the if I just done this, it would probably, well, I have to do some like negative things around it, but something like that maybe, because keep is max, but then that would have been good enough. But I think I just misread that one a little bit, or at least I misunderstood the constraints a little bit. Uh, yeah. Uh, Let me think about a window. Um, yeah. What else to say about it? But yeah, but once you, so that's what I do with the party queue, and I was thinking of trying to figure out a way to almost similar to Dijkstra, if you think about Dijkstra algorithm, where um, there's stuff in the priority queue or a bag or something like that, and then you remove it, and then the priority queue would automatically trigger itself. But instead, I did this other thing where, and it's still going to be n log n, and I think that's the big uh, yeah, n log n is you don't get it to n log k, but that's okay. At least for this problem, if I had gotten it right. But the idea is that we take the max element that's in the bag, and as long as that max element, and then we keep track of the index as well. As long as the delta of the index is smaller than k, then we play around with it. Otherwise, you just keep on popping until that's the case. And I do a little bit weird thing because in Python, heaps uh, maxed is sorted by max. So that's why I have some like weird negatives here, which also threw me off a little bit because I always forget.